Yeah, I think I pushed. Yes. So this video is Physics25CBlake. And back when you were in physical science, you should have studied about simple machines. And so we're going to talk about this a little bit, because if you did a lab on that with simple machines, it would be a little different. Well, it would be probably quite a bit different from the one I set up, because we wouldn't have had the same machines. But if you remember last year when we shut down for the pandemic, this was actually set up in the room, and the physical science students were doing this. So you have seen this, and I also had my physics students run through that lab. So I will have you do that when that time comes. But there are ramps, and this is a ramp problem. And I just took this out of the physical science notes and plopped it in here, where IMA, or ideal mechanical advantage, is the length of an incline over the height of an incline. And in our problem, I also just picked the graph out of there, and it was 13:2 or something like this. So it's not really 5 to 1.5. This is too long and this is too short. But you get the idea. You've got a ramp like this, and you can just divide those numbers to get it. So if you use the physical science approach, where we're talking about mechanical advantage, which is really not part of this chapter. So this isn't, don't scribble all this down, because you're going to use more of this later. But the IMA is the length over the height, and that's 5 meters over 1.5, which means the mechanical advantage of this machine without friction, this ramp, should be 3 1/3. And if there is no friction and the efficiency is 100%, then this 3 1/3 we can use for AMA, and we can find either one of these forces if we have the other one. Output force divided by input force is AMA. And you probably should have had some kind of lab where you did something like this. So if I put my 3 1/3 here and I calculate force in, bring this up, put this down here, divide, I come out with 360 newtons. So if you do it kind of the way a physical science student would, you're either going to pick the fridge up with 1200 newtons, or you're going to push it with 360. And if you push it with 360, you're going to go up a longer ramp, and the force will be less, but the distance will be greater. If you pick it up with 1200, the distance will be less, but the force will be greater. Either calculation gets you the same work. So here's the way you would have probably done this if you did this problem like you should have before you looked at the answer on here, like you should have. You would have calculated, oh, we've got a downhill force, and the purple line here is mg, it's the weight, and we don't have friction, so I don't have to worry about this normal force, but my downhill force is mg sine of theta, and here's where I had my flash of inspiration here, so I got a purple exclamation point. Sine theta is opposite over hypotenuse. So I take this opposite over hypotenuse and divide them and get the inverse sine and put theta, and then put theta in here and take the sine of it to end up with the same two numbers. If sine theta is opposite over hypotenuse, and you've got opposite over hypotenuse, just stick them in there and be done with it. Substitute OH, O over H, in for sine theta. You don't have to run through all that rigmarole. And when you do that, and you take 1200 newtons times 9.81 times 1.5 divided by 5, you get 360 newtons. Now, what happens is, if there's no friction and there's 100% efficiency, picking that 1200 newtons straight up for 1.5 meters is the same amount of work as applying 360 newtons up a ramp 5 meters long, as long as there's no friction. So it doesn't matter. The work is the same either way, as long as there's no friction. So the work is 1800 newtons in each case. However, the ramp is generally considered easier for a human because the force requirement is less, distance requirement is greater, and we can manage that better. Generating sufficient force is an issue for humans due to ergonomic concerns, etc. I mean, if you lift in the fridge, you got to lift yourself and the fridge, and your body's not really shaped to do that kind of thing as much as it is pushing. Now, even if there's friction on the ramp, you're still better off to use the ramp. You will actually, if there's friction, have to do more work, but you can achieve that amount of force more so than picking up the heavy object. Okay, which brings us to the end of the chapter questions, and I think I am going to stop there. I think that's plenty of work for us, plenty of video at least, to get us to Wednesday. And if we get through all this, you can start working on the problems on Wednesday and look at the solutions later. So that's enough for now.